So in the previous video we did some static analysis of this binary that's on my virtual machine's desktop here, this 267.exe, and in this video we're going to actually run the malware and just try to pull out some indicators from what it's actually doing. So we're going to do a bit of behavioural analysis here by actually running the malware. So first of all, what I'm going to do is just open up Process Hacker and I'm going to run that as administrator. So when we run this malware, that'll allow me to look at the actual memory of the process that's running and pull out some indicators. And we're also going to run process monitor or procmon. I'll just kick that off now. So I've got a filter here where I'm just filtering on any processes that are created, so we can hit OK on that. And that's now capturing, but because no new processes have been created yet, it's showing as blank, which is fine. And we've got Process Hacker here on my desktop. So what I like to do is just right click on the malware and run it as administrator, just give it full privileges, and hopefully we can then just give it the full capability of what it's been designed to do. So I'm going to run that now and click yes on this UAC, the user account control. And if I just scroll down to the bottom, we can see 267.exe running. That's fine, we'd expect to see that. And we'll just see if it creates any other processes. And we can see that's just disappeared and a new process has been created, this loaded tangent.exe. And we can see this pop up here in the bottom right that says a service has been created. So what's happened here is we can see on the procmon, like I say, the new process is being created. I'm happy we've got enough information with that for now, so I'm just going to do file and stop capturing events on that. And like I say, we can see the new process running here. So I'm just going to right click on this, and what I'm going to do first of all, I mentioned that you need to run Process Hacker as an administrator. And the reason for that, like I said, is we want to look at the memory of this process and see what information we can pull out. So I'm going to click Properties, and from the tabs at the top on the right hand side, I'm going to select Memory, and there's an option here for strings. So I'm just going to click that as well, and then click OK. And here we can pull out all the strings from the process that's running. And particularly what I like to look for is any IP addresses or domains, just to sort of show any connections that the malware might be making. So on the bottom left hand side, there's a button here for filter, and I'm just going to click on regex case insensitive, and then we can enter a regex pattern here to start searching for any indicators. On my host machine, I'm just gone on to CyberChef. We've used this before in previous videos, and I'm going to use the regular expression operation here and just drag this across. And I'm going to look for the user-defined ones of IPv4 address. So here's a regex that will pull out IPv4 addresses. So let's copy that. Let's go back to our virtual machine and let's just paste that in there and click OK. And straight away we can see some IP addresses here that have been pulled out. So these are going to be the command and control, so C2 IP addresses of the malware. So these are basically the IP addresses of the servers that the attacker who's designed this malware is running, and these will be making connections to these IP addresses and possibly exfiltrating data from our machine. So again, I could start copying these out, adding these to my incident notes. If I just scroll down, is there any more? And we can see at the bottom we also have some directories here and some other addresses. And we can also plot the ports as well, as you can see here, 443. Was there anything else there? No, but like I say, we've got some sort of information that's definitely useful. So again, if this was an incident, we could take these IP addresses, start looking in our proxies and start looking for any other infected machines. And that will give us an idea of the scope of the incident. You know, what machines are infected, where do we need to remediate, where do we need to do our containment. So like I say, you get those copied out and added to your incident notes. If I just close that down, and I'll just terminate this process for now because I'm happy that I've got enough information from actually running the malware. So I'm just going to click on terminate tree and just terminate the malware and stop it from running. And if I just go across to procmon, like I say, we can see the processes that were created. There's the 267, and we can see the location of where we ran it from the desktop. And we can then see that another process was created, but from a new location. And this was now running from Windows syswow64, and it's now called loadertangent.exe. So what's happened here, if I just do Control-T and look at the process tree, we can get an idea of what's happened here. So again, we've got the location of the malware originally running, so it's 267.exe from desktop. And what it's done is it's spawned a new process there. And I've mentioned before about how malware is packed to stop us from analysing it. And what's happened here is the malware has actually unpacked itself in memory. So what it's done is it's created a new process, it will have hollowed it out, so it will empty the content of the process out, and it will then have injected the unpacked malware, the unpacked code into this process. So this is called process hollowing. And what it's done here is if we have a look on the right hand side, we can see on this command tab, this --9cf58951. Not sure what that is, but it's obviously passed itself an argument. What it's then done then is obviously enumerated the location it's running from, identified it's not running from where, its persistence location, and it's copied itself to this syswow64 and renamed itself to loadertangent.exe. Again, it's then unpacked itself, created a new process and injected the unpacked code into this process, and is now running from what's called its persistence location. So this is where the malware will remain, and it's probably created some sort of persistence mechanism so that if the machine is rebooted, it will then fire up upon rebooting the machine. So let's say the machine's restarted, the malware will be fired up. So we've got some useful information here about how the malware behaves and what it's doing. Like I say, we don't know what these flags are yet, this -9cf and this, again, when it's sort of moved to its persistence location, this -4647. But again, when we start getting into debugging and running this malware through X32 debug, we might be able to glean exactly what that's doing. Like I say, it's possibly something to do with identifying the current location, enumerating the location of where the malware currently is, so it can then copy itself to its persistence location. What I then like to do, because like I say, I've got a filter on here on procmon, which sort of keeps it neat and tidy, and I can sort of see what processes have been created. But if I was to do, say, a filter, well, let's just say if I was just to remove that filter, apply that, and again, I've mentioned this before in the bottom left hand side here, these hundreds of thousands of events have been generated here. So the best tool for analysing this data now is procdot. So what we need to do, whenever you're using procdot, you'll need to export this data from procmon. And one thing just to be aware of, on your columns, if you right click and do select columns, you need to make sure that this thread ID box is ticked here, and then click OK. And if we do File, Save, I'll just do all events, and I want to export this as a CSV, and I'll move the output to my desktop and just click OK and save that. And if I just minimize this now, we can see this log file now has been generated on my desktop. So let's fire up procdot. And to import the CSV, you can see this procmon option here underneath monitoring logs and these three dots here. So you just click on this and select the CSV that you want to import. And then on the next part here on the right hand side, you can see this render configuration and launcher. If you click on the three dots on the right hand side, and it's going to analyze the procmon file now and pull out a list of processes for you to get a graphical representation of. Now, depending on how long you're running procmon for and how long how much data you recorded, it can take a while sometimes to do the analysis and generate these sort of graphical representations of the data. So that's now loaded, and it's now asking me to choose a process name. So I'm going to choose the first one that we generated, which was this 267.exe. I've double clicked on that, and then I need to click this refresh button on the right hand side. And again, that can take a while depending on how much data you've recorded and how much has been captured. So we can see our graph has been generated. Now I'm just going to maximize this. And like I said, this is just a really nice way of sort of analysing of what the malware is doing. It'll give you hopefully some key indicators and some key information on what's going on. So I'm just going to hold Control and scroll in there with my rolling mouse button. And we can see we have these 267.exe here. It's telling us that it's created a new process with 267.exe. Well, we saw that. That confirms what we saw in Procmon and in Process Hacker. We can then see what's it done here. It has then renamed itself. So again, that's what we confirmed here. It's sort of moved itself to a new location. So it's created this loader tangent.exe and renamed itself. So again, that ties in with what we saw. The malware's moved itself and renamed itself. And we've also got this additional information here. We can see that, you know, as I mentioned before, it's possibly moved to its persistence location. And we can see these run keys here have been created which mention auto start. So again, when the malware, when the machine is rebooted, the infected machine, that malware then is then automatically started and loaded, and it will carry on doing whatever it's doing, given the attacker remote access or exfiltrating data. So just from that quick 10 minutes of analysis, we've pulled out the C2s. And we've pulled out the persistence location, the name of the malware, a bit of behavior, so it deletes itself from the desktop, moves itself to this new location, and we've identified its persistence mechanism.